ou il y a des pièces rapportées, non? En quelle année est-ce que vous êtes? Vous en êtes où de votre parcours, à peu près? Au milieu? Ok. Tout le monde est à peu près au milieu? Qui est à peu près au début? Qui est à peu près au milieu? Au début, ok. Au milieu, donc vous. Et il y en a qui sont vers la fin. Ah, lui là-bas, il est vers la fin. Il s'étouffe. Est-ce que vous êtes familier de la blockchain? Ouais. Qui a un compte blockchain? Un wallet, non? Quelques-uns. Ah, il lève timidement la main. Faut pas que ça se sache. C'est bon? On y va? Ok. Bon, bah, bienvenue à tous. Je m'appelle Luc Bocahu. Je travaille chez XRPL Commons. Je vais vous dire dans un moment ce que c'est. Je suis directeur produit et architecte des solutions. XRPL Commons, je vais vous en parler un petit peu aujourd'hui. Je vais aussi vous parler de la blockchain en général, essayer de mettre un peu tout le monde à niveau. Et puis je vais vous parler en particulier d'une blockchain sur laquelle on travaille, qui s'appelle le XRPL. Et puis je vais... est-ce que vous avez des ordis ou pas? Toi, je vois que tu as un ordi. Mais je vais vous montrer un bout de code à la fin. Je vais vous montrer un peu de code, comment... parce que quand même, on a un public un peu technique, donc on va en profiter un petit peu pour s'amuser. Oh, I should do it in English? Oh, I prefer to do it in English, so... Okay. So I'm switching to English. Is everybody okay with that? So actually, you'll notice that some of my slides are like half French and half English because all this material is in English and I translated a lot of it. So great, we can do it in English. Fantastic. So the first thing I'm going to mention is for those that have a computer, later on in the session, at the end of the session, I'll be using Replit to do the code demonstration. If you want to follow along, it's really easy. It just takes a few minutes. But while I'm talking, you guys can probably just go on Replit and sign up if you don't have an account yet. So I just mentioned that as a little preamble. So XRPL Commons, we're a nonprofit. We're based in Paris, and our mission is to create the conditions of success for entrepreneurs and developers in the XRPL ecosystem. And so we do this through a number of initiatives. We call them pillars: the learn, build, adopt, and engage. So what do we mean by that? So learning is all of our initiatives around academic partnerships, so working with institutions like the school, providing learning resources, trainings for students, but also for instructors, because we need to train a lot of people to come and build on the blockchain. We need a lot of engineers. It's a domain that is in dire need of engineers. And we coordinate research, and we have with me Vera here, who is the point person on the educational side. Build, we run a number of programs. We run hackathons, and some of you may have participated or heard about them. But we also run a residency, which we feel is something that we wish we had when we were aspiring entrepreneurs building projects. And it's a 12-week residency based in Paris. And it's a full-time residency that's happening in our headquarters. We are in the center of Paris near Rue Beaubourg. And we have a number of themes that we go through. So we've gone through now 3 cohorts. So I should say we're a young association. We've started about a year ago, a little over a year ago. So we've had 3 cohorts so far. One around regenerative finance, one around in intellectual property, and this one that is just finishing in in a week's time exactly around digital identity. The next one will open in September. We'll start in next September, and it will be around DeFi. And probably the one after that will be around gaming. We work on adoption, so trying to get corporates to come and provide projects, build on the blockchain in general, and build on the XRPL. To provide opportunities essentially for startups that are built in the ecosystem to have an opportunity to address real clients. And finally, our engagement activities around meetups. We run a podcast. We have a nice community magazine. Actually, unfortunately, I don't have any of them with me right now, but you can download them. You can find all of these things on our website. You can find out more here, but it's pretty easy to remember, xrplcommons.org. So that's us in a nutshell. So do you guys know what's a blockchain? So I was just asking this question. I think a lot of the people here in the audience already have wallets. For those that don't, I'm going to go through what, and even I think for everybody to sort of be on the same level playing field to understand, what is this object that we're calling a blockchain? I'm going to go through that. If I, at any time, I'm going to try and go a little fast because I know we only have about an hour. There's a lot of content. If I'm going too fast over a subject, feel free to just raise your hand. We can jump in, ask questions. So just going to go right into what is a blockchain. So we propose this definition. It's an immutable, distributed, decentralized database that coordinates heterogeneous actors. Okay, so all of those components are important, and I'm going to go through them one by one. So what do we mean by immutable? It's an immutable data store. It means when we write to the chain, we expect to be able to read it forever. And this has very important implications in terms of what data you can actually write on a chain. We'll go into some of the details around what different types of blockchains, but most of the blockchains that you will interact with are public. And so if you're writing data on a public blockchain, even if it's like super obfuscated and encrypted and all that stuff, at the end of the day, you should expect that someone eventually will be able to read it. But it also means that it's a way to write data in a way that will be tamper-proof and will be there forever, which is a big advantage. It's distributed. It simply means that it's replicated across many, many servers. This basically gives it the censorship resistance properties. You can disconnect a server. I'm sure you guys are familiar with clusters and things like that, but essentially you can shut down some servers. The data will still be there. It's been replicated. It also means it requires significant infrastructure to run. You can't just pop up a server and have a blockchain. The actual value comes from it being distributed around the world. And the big one, it's decentralized. So what do we mean by that? Well, we mean by that you can when you're writing, when you're interacting with a blockchain, you basically have to decide. You basically have to figure out what is going to be actually written on the chain. Someone has to have sort of control over what data is actually written and what data is rejected. And the way decentralization happens, essentially you can think of it as it's a preliminary contract. You decide beforehand on what the rules of engagement are going to be. When you're interacting with any of the chains, you're implicitly abiding by those rules, deciding to adhere to the rules of how the consensus is made. And so the consensus is the mechanism by which the data that's written on chain is decided to be actually written on chain and to be the truth. And so there are many different types of consensus mechanisms. You might be familiar with the blockchain, the Bitcoin consensus mechanism, which is proof of work. Ethereum has proof of stake, and many chains have proof of stake. And there's a whole slew of other different, as many really as there can be forms of organization. So you have to keep that in mind. Proof of association that I have here at the bottom is the the consensus mechanism that is used by the XRP Ledger. And I'll get into that a bit later. It's a database, right? We're writing data to it, but it's a very specific kind of database because data is being written sequentially. What that means is that every time we're writing to the database, it's adding a layer at the end. It's for some of you that might be familiar with computer science, it's basically an event store. This has implications. It's designed this way because of the way we're writing to the data, to the blockchain. But this has implications when we're trying to read data from the blockchain. It's not really written in a way that's very easy to retrieve. So even though the data is there, you might have to go back in time and reread previous things that happened. And importantly, I think the main use case for blockchains are to coordinate heterogeneous actors. What do we mean by that? If there was one single person that controlled what was written on the blockchain or who could do what, you don't really need a blockchain because you don't really need consensus. You don't really need all of these features, and they are very costly features to implement. So heterogeneous actors are actors that might have different interests, that might be adversarial, that might be aggressive, want to, tamper with the data, change things, and really blockchains shine in coordinating large groups of heterogeneous actors. Okay, so you can think of that as you can have your clients, your competitors, different types of different suppliers that can interact with the chain. The advantage comes from the fact that everybody is only one hop away from the data. You can easily read and you can easily write. There's a contract that has been predefined, and it's very easy to get access to the data, and no one can prevent you from having access or writing to the chain. And coordination in a public blockchain happens in the open. You can see the coordination happening. So we put it all back together. It's an immutable, distributed, decentralized database coordinating heterogeneous actors. Is that okay for everyone? Is that clear? So once we've have this definition, we can see how not everything should be on blockchain, right? There are limits. Speed is an issue. Sometimes it takes some time to write to a blockchain. It takes about 10 minutes to write something to the Bitcoin blockchain. It takes different times for you might even have to wait before the data is final and sure. You might have to wait even longer. So speed is an issue. Cost, obviously, infrastructure. And it also has limited storage. We can see this on Ethereum-based chains. There's a major problem of, people are competing to write things to the chain, and so you don't want to just dump all your data in there. But it really is ideal, and it shines for community-based services, where communities are getting together and doing things for each other, and this is an example I use. It's like you can think of like the best use case to be something like a decentralized marketplace. So you can think of like Amazon being decentralized. It wouldn't be controlled by one actor. We would establish the rules beforehand, and the infrastructure would just run, and you could do the thing without having a central player in the middle. And of course, that opens up many use cases. I was just talking about the limitations, but there are many, many use cases that the blockchain is used for today. Okay, so key concepts of the blockchain that make it possible, make it work, that you should have in mind before interacting with the chain. First of all, there are two types of blockchains. There's private blockchains, which could be at the level of a group of companies, a consortium that don't have open access, that are completely isolated from the rest of the world, but actors coordinate, use this tool to coordinate. And then we have the most known blockchains, which are public, like Bitcoin and Ethereum and some others, where it's really more of a public good, and you can use it for public services, governance, and you can write proofs of things that need to be more public. Another really important concept is that makes it all of this is made possible essentially by cryptography. And the most basic way to explain this is going to a very specific function called the hash function. And the hash function essentially takes any text, any string, and transforms it into a fixed length string. And the properties of this algorithm are that you can very easy to go from the plain text to the hash text, but very difficult to go the other way. Quasi impossible. So this is like a fundamental building block of why something like blockchain is possible. Because once you write things and you use these functions, you can make sure that things can't be tampered with. So how are blocks made? Well, blocks are essentially lists of transactions that happen in a certain time period. So I have a couple examples, some transactions that happened. We take all those transactions, we hash them. The whole block can be hashed, and we use this hash as the starting point for the next block. More transactions come through, we hash that, etc., etc., etc. So the chain of blocks is called a blockchain. So now you see how you go from hashes to blocks to a blockchain. So I could actually try to show you. Hold on. I'm going to do a cool trick here, maybe. Oh, sorry, I should have had this running already, but it's fine. Just going to take a sec. So I can show you what that looks like in real time. Depending on the internet connection, we should start to see something. So here you have blocks being written in real time, transactions going through. Every single one of these icons corresponds to a transaction, a different type of transaction, and blocks are just created. So these are real transactions, real blocks that are happening right now. Pretty cool, right? So, oops. I'm kind of doing my thing here, okay. So, okay, so I showed you how blocks are made, but so how do you write data? How do you, claim ownership? Well, you use basically an extension of this hash function, a special kind of hash function, which basically creates two different parts. When you initiate it with two different parts. The public key, which is basically going to be your address. So it's used to encrypt information destined to the holder and to verify signatures, but it's also where to identify it's your public identifier on chain. And then the private key, which is never shared on the network, which never appears, which you can decide to hold yourself, or you can decide to give it to a custodian, trusted person, trusted service that would keep that for you. But essentially, this part is the secret. So you have an address and you have a password, essentially. And with this, you can sign transactions. Any questions? Okay, great, good crowd. So we talked about transactions, and we also have little pieces of data. We're manipulating data on the chain, and data is materialized in different ways. The main ways they're materialized are fungible tokens and non-fungible tokens. You can think of fungible tokens as things that you can mix and and break into however many points you want. You have a question? So there's many. So you're asking, are there variations on? Are there semi-fungible tokens? So there's definitely that too. The key thing here is that fungible tokens are one extreme, NFTs are like another extreme. Fungible tokens are things that if I have one of them and I give them, you can't differentiate with another one. They're the same. They're interchangeable. NFTs are unique. Like they identify. It's like essentially it's a DRM. Like it really it shows the unicity of a digital asset. So it's one. It's unique. You can't break it up. You can't do anything like that with it. And then in the middle, there's a range. You can do these are just pieces of data, right? The non-fungible tokens are really, really useful when you have to identify a specific object and you have to say, like, I don't want there to be any forgery of, like, this represents this specific object. And fungible tokens are really, really useful when you're trying to do currency exchanges and monetary emission. But of course, there's tons of use cases in the middle where you might want to have parts of the thing change, or you might want to be able to break it up, but only a certain number of times, or limit things in certain ways. And so there's many, many different variations. On the XRP Ledger, we'll have fungible tokens. Will be there's basically, we call them IOUs, and we have NFTs, and we're right now adding something called multi-purpose tokens, which basically cover all the spectrum between both. But you're right. There's many implementations. I should add that typically NFTs are completely unique and you can't change them. But now we have standards where you can change parts of them. So they're not fungible, but they can be changed. So here I wanted to talk about, at the core, what are we doing when we're interacting with the blockchain? Is we are building chains of proofs. Anything we read or we write on the blockchain is essentially a proof. We can prove who wrote it. We can have there's all sorts of mechanisms on chain to say this was done when at a certain point in time, and I can verify it. It's completely verifiable. But it's also, why do we do this is because we want to reason about these proofs. We want to reason about verified data. And the way we interact with verified data is basically by building chains of proofs. So for instance, if you wanted to take something from the real world, like a measurement or something, you would have to probably trust the device that is taking the measurement. And then you could be sure, if you trusted that device, if you could somehow, you have some logic to make sure that that is the device that that is taking the measurement, then that measurement can be written on chain. And now it's verified data. It's true. And then you can start reasoning about it. So maybe it's the price of something, and you're going to trigger some effect because of that. It's very important that the chain of proof be respected. If you're writing random data, if this device all of a sudden malfunctions or is replaced by something else, and writes, it could definitely write that data on chain. It would be proved that the data was written. You could verify that the data was written, but you need to think about all the way through, like, the chain of proof, right? And when you do that, I mean, that's what we're actually doing. That's why we're doing this. Then you can start to do interesting things. And so there's different types of proofs. So I was just talking about the physical world proofs. You also have in the digital world, you can prove things that are unique or things have changed hands. So that's like NFTs. You can also prove now that certain algorithms have run, or certain models have run with advanced cryptography. So that's really interesting. So you can actually verify that this calculation has been done by the right program. It's there's a whole literature about that, but essentially that's the whole ZK proof thing. And then you have proofs that are derived because you're on the chain, they've been written on chain, and then you're taking many proofs and you're combining them and you're creating other, proofs. But essentially it's basically all this is like data we're writing, right? So all the data that's on chain, we try to make it verified. So useful data. And then once we have all this useful data, we can start to programmatically reason about it and do interesting things. And so that's where smart contracts come on. And finally, I want to leave this section also with the idea that in a world that is more and more digital, verified data is more and more important. And so blockchain, and I think there's a talk about artificial intelligence later, are two technologies that are eventually converging, because they're both in the digital world. So both like as data that needs to be reasoned about, a model is only as good as the data that comes in. So if we have good data, it's better. But also to verify that, okay, if you're talking to your agent, are you talking to the right agent? Has someone come in the middle? Is someone tampering with the? Has someone tampered with the models and the weights and in some subtle way that you can't see? So blockchain helps with all of that stuff, and we've seen also many use cases used where the blockchain is used as an interoperability layer, meaning that we can coordinate different agents and different actors on-chain. So you can think of this, the easy sort of image here is to think of like what an autonomous vehicle would do. Autonomous vehicle is, transacting with clients, that it's, moving around, right, getting them from point A to point B, but then they need repairs, they need, fuel or energy or whatever. And, all of that can be programmatically built in, but these agents need to actually, be transacting and do verifying data, being identified. So there, that's blockchain. I think now we're at the stage where we all have a good understanding of what blockchain is, what it can do, where it's going. I'm going to talk now, excuse me, about the XRP Ledger. So to talk about the XRP Ledger, we have to kind of go a bit into the brief history of blockchain. Blockchain is not very old technology. I mean, the first, the real first blockchain was created in 2008. Bitcoin. Very early on, so it was built. We know about it in 2008, 2009, but of course, it's relying on works in cryptography and the works of researchers that have, that's happened, decades before as well. But it emerged very recently. A little later, right about after, the XRP Ledger was created, and then anyway, I'm going to actually go through the a little bit, but basically the point here is that it's a relatively new technology. And XRP Ledger is one of the oldest in the game. And so Bitcoin, I just talked about. So when Bitcoin was created, almost immediately, this is actually just this is the first time that people started talking about the XRP Ledger, or the idea behind the XRP Ledger. And the XRP Ledger came from a criticism of Bitcoin, and specifically the way the mining protocol was very resource intensive and wasteful. And the idea in this discussion, and you can find this discussion online, it's very easy to find. It's actually kind of interesting to see that a lot of these criticisms like happen very, very early on. And essentially, the idea is, well, all this mining is using up a lot of energy and a lot of resources, and could we do things differently? And so that's that's where the idea of pre-mining came from, and creating lighter weight consensus protocols came from. So the XRP Ledger was born from that. And from its inception, it focused on solving the problem of payments. Then a little while later came Ethereum, who came out of the box with smart contracts. Last few years, the few years after that, were a slew of new chains were created, new use cases. NFTs became huge, and I would say now we're in a period where it's all about how do we scale away from the limitations of current blockchains, which are limited in space, and how do we create layers and layers and live in a multi-chain world. And so what we're seeing is specialization of chains. So the XRP Ledger essentially was created with the original idea was to just allow for money transfers to happen easily around the world. So it's still a major problem today. Banking makes it very difficult to transfer money from one country to another. There's lots of intermediaries, and the idea was, well, if I know someone in the other country, why can't I just, send him the money and wire him the money directly? Use this technology to do that. Essentially, that's where it came from. Sure. The difference between XRP and Ripple. So Ripple. So the XRP Ledger was created by the same people that created the company Ripple. So Ripple is a company that has some services around payments, mostly institutions, not really retail. And they open sourced the ledger, which is called XRPL, and that's what we're calling XRPL. And now it's a community-driven project. So and the code is open source. And XRP is the native token of the XRPL. So you got one is a private company, another one is the actual chain, and the final one is the token. Ripple uses and continues to develop and grow the XRP Ledger, but many other contributors also participate. So this is just a couple of statistics. Anyway, it's one of the largest blockchains. So XRP Ledger, it's a public register, same way Bitcoin and Ethereum is. It's open source and decentralized. It's been running for 12 years without interruption. The one of the key features, it's a 4-second settlement time. So basically, it means you have to wait maximum 4 seconds between the time you put a transaction through and the time it's final. So relatively fast. It has, because of the consensus mechanism it uses, it has a very low carbon footprint. It doesn't require massive servers to run and so on and so forth. And it has many different libraries to code. So I was talking earlier about the type of consensus. It's a proof of association consensus, meaning that we determine a certain amount of validators that we trust. And so we have right now in what we call there's the main node validator node list, which we call the UNL. That has 35 different validators on them, and none of them, well, they're all independent entities, essentially. The idea is that no single validator on the UNL can control more than 5% of total assets, of total validating consensus mechanism. The total validator pool, basically. And for consensus to happen, 80% of the validators need to agree. So it's a bit different. These metrics are a little different than you might have heard from other blockchains. Essentially, it's an explicit trust. But when you run on the network, you can decide who is on your UNL. You can decide to use the public UNL, or you can use another UNL of only the people you trust. So it's open in that way, but to facilitate the good operation of the ledger, there is a list that is provided for you that you can use, and that has been vetted. In other words, there's no mining, meaning that there's no computation that's happening on the validator at the validator level to actually, there's a lot of computation, but there's no computation competition that's happening between the validators, or they're not trying to solve like a complex math problem or anything like that. And there's no incentives for the validators to run a node. What that means is that they don't get paid anything to run the node. So the only reason they're running a node is because they are participating in the network and they want to use the network and they want the network to be stable. And so these are typically majority of institutions, but some individuals as well. The fact that there's no mining, the fact that there's no incentive for the validator, makes it allows basically for transactions to be extremely cheap. You can run thousands of transactions for less than a cent, and that has other interesting implications as well. On the flip side, there are some mechanisms to prevent spamming. And so when you create an account, because space is limited, we don't want people to just, spin up activity that is not required, that is not valuable. There is a reserve requirement, costs about $5 to 10 XRP essentially, to create an account. So you have to have a reserve. When you close the account, you can get most of it back, but that's a spamming. So that's one of the limitations. But once you're in, all the transactions are very, 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 very cheap, and all the there's still a little. You still have to pay a little bit to put your transactions through, and in certain circumstances, that price could go up, but in practice, it's never gone up. There are some defense mechanisms against attacks that would push that if there were many transactions all in a very, very short time, validators might decide to raise that. But anyway, basically what that allows is for a lot of transactions to be able to go through for very cheap. And if you have that, and if you've ever been in the blockchain space, you know that the gas fees and the transaction fees are very, very important, and the control of the expectation of the price is very important. And having these very, very low transaction fees allows for some unique features on the ledger. One of those is a unified DEX. So the DEX is, so right now, actually, I think we're calling it the super DEX, but the DEX is it's an order book. So it's a market it's a market facility. It's a market tool, basically, that takes all the bids and all the offers and collects them in one unified place and allows you to transact. If transactions were really expensive, you would only be able to do that for very expensive assets, because if I put an order through, it may or may not get filled. Every time I'm putting an order through, it's costing a transaction to go through. The fact that transactions are so cheap, that allows you to basically run a proper order book on chain, and it's at the main protocol level. And then recently we added automatic market makers, which are essentially automated swapping facilities between two currencies. And those are integrated into the DEX. So it means that if you're putting an order through to swap two currencies, it will find the best price for you. It will either go to the AMM or to the DEX, and if it's on the DEX, it might even hop through a few pairs automatically. All of that is included at the protocol level. You don't have to do anything to make it work. It just works out of the box. And it's a fixed function ledger, which means that the functions of you can think of it as it's a very, very large smart contract that has 30 plus transactions in it. And what that allows is basically that we have a single API endpoint, you connect to it, and you can start interacting with the chain. You don't have to have any more complexity than that. It's basically integrating with the XRPL is as simple as integrating with any API. So one endpoint allows you to do all the things. So you connect to it, you can do payments, you can create, mint, burn, etc. NFTs. You can do all your monetary emissions. You can deal with transferring real-world assets. You can do, of course, like advanced account management. I mean, these are because it's been around so long. All the features that have been built around the account management and the are designed to be user-friendly. So what I mean by that is, if you're concerned about your keys, you can just create a regular account, that basically a regular key that has the same properties as your main key, except that if you lose that, you can replace it, or you can actually, if it gets compromised, you can delete it. For instance, you have things like being able to prevent accounts from sending you. You can decide only to transact with certain accounts, and so on and so forth. AMMs, I just talked about. Basically, bots, swapping bots. DID, decentralized identity, is an important new feature, and then of course bridges to other chains, interoperability, very important. So single API, minimum code requirements. So I can show you how it works if you want. So I'm not getting the impression. Are you going to code along? Okay. Because we could just basically do this from scratch, but I'm just going to maybe just read through it. Can you guys read that? Is that good? Is that good? You can read it? Okay. So this is a basic TypeScript. So we start. So I still have some commented code in there, but anyway, the first line, we're just basically importing the SDK. This we do during the training. We do a training every 2 months, and we go through all of this in much more detail. And we actually go through this just this script, and that's one of the first workshops we do. So you import XRPL, so that's a pretty straightforward thing. You create a new client, and you just point it to the right endpoint, okay? And then this thing here, this is your main function, right? So this is a little structure, but basically sorry, I'm just gonna delete all this useless stuff. Anyway, so, I have a main function, and then I'm calling the main function here from the bottom here, okay? But essentially, what do I need to do? So I'm calling it from the bottom. I connect my client, and now I'm ready to send transactions through. So the first thing I do is, because I'm pointing this to testnet, I can easily create accounts. And this one line basically allows me to create an account and fund it. So I create account 1, wallet 1, wallet 2. Here I'm just showing you I'm just logging that. So why don't we just start with doing that. Might be hard to code with a mic in my hand. So anyway, I'll just run that. So you'll see the first steps is it's just going to be basically create the wallets, and you'll see how long it takes. So actually right now it's actually setting up NPM and all of that. Okay, now it's starting. Funding to accounts. And it's going to print the, here I'm just printing the balances and the addresses that are created. Great. So I created my wallets, and I have my balance, and then it broke. But anyway, so I created my two wallets. And no, sorry, I'm not on the wrong page, sorry. Okay, almost there. So here, this is my account. I have 100 XRP in it. So this is the Explorer, right? This is another way, another way. This is a way for me to read stuff that's on the chain. So I push this command through, and I was able to create those wallets. And then actually, what I really would be interested in is I'm not really going to do that. You can learn about print money if you come to the training. That'll be a little teaser. And then I'm going to do a payment from account 1 to account 2. I'm going to transfer over 18 XRP. And at the end, I should want to print this. So let's see what happens. So what is a transaction on chain? It's basically a JSON object with a couple keys and values. Pretty simple. Here I'm submitting the transaction, and now I'm just reading the balances of the two accounts, before and after, right? So at the end here, I've created these two accounts, and one of them has 118 XRP, and the other one has 81.999, et cetera, et cetera, et cetera. But because there is a little bit of XRP that's been burned, tiny amount, yeah. On testnet. You wish. That's why I created the print money function. It used to be 10,000, but anyway, they changed it. I mean, I can't think of a use case where you would need a lot. Just because you typically use drops, and it's millions of XRP, so. But yeah, come to the training. I'll show you the print money function. Sorry? The training is Monday and Tuesday. Next Monday and next Tuesday. Okay, so was pretty simple, right? Which I literally just imported a library and connected to the thing and sent the thing, and we can find the transaction on the ledger. So as I was just saying, we have a training on the 24th and 25th. This time, so we always have the first day is basically everything about mainnet, and we do, we start with like teaching you most of this, more advanced than I did here, but like a longer form, like what blockchain is, what can you do, what are the use cases, so on and so forth, how to think about it in your projects. And then we go about showing you all the different features that we have. So we're going to do this time. We'll do something similar to this. We'll set up your actual wallets on your phones with everything, so that you're all set up. That takes us through the morning, and then the afternoon we'll do AMMs, which are essentially a new, well, a monetary emission and AMM. So how do you create a token for your community? How do you provide liquidity for it? How do you do all of that? We'll cover all of that in the first day. The second day, this time we're really excited. We're going to have some real hardcore developers from a sister chain called XHAO, which essentially takes all the nice features of XRPL but adds some programmability on it, and they are going to show us how to work with this version of smart contracts. It's all JavaScript, so you can write your smart contracts in JavaScript essentially. So it'd be a really cool session. Yeah, so that's the training. Of course, I mentioned the aquarium residency that's happening starting in September. So you can apply now. You can find that on our websites, and we are looking for interns. We're looking, starting in September, 6 months. Come if you're interested. Come talk to me. If you know someone that's interested, just send them my way. And we also are hiring developers and people. So come talk to me if you're interested. If you feel you can contribute. So what do you? I'm sorry. With Visa and MasterCard, you said? Yeah. Absolutely. Yeah, you can absolutely do that. You can also integrate with a credit card provider and to run the transactions through the. So, Visa and MasterCard do a great job of connecting the world with all those terminals, and so that's great. Where those terminals, those credit cards are accepted, it works great. When you start to have some level of competition with them is when it's like the cross-border payments. Cross-border payments there's issues with exchange rates. There's risks involved. There's all of this that's happening. The way Visa and MasterCard do it, they don't settle the transaction immediately. They kind of give you credit, and essentially you don't necessarily know this as a user, but they basically they're providing credit to the well, essentially the vendor is providing credit to some extent, and they're collateralizing it, and then it's settled maybe the next day or something like that. This settles immediately. So that's one advantage, and it's also cheaper. So, but there's definitely some work to be done. What I tell the residents always is when you're thinking about building a project on blockchain, don't aim for people that are crypto natives. Aim for use cases that address the rest of the world, because the blockchain space is still very small. Even though it's exciting, there's lots going on. There's a lot of cool tech being built, great builders, and all of that. We still haven't onboarded most people. Most of the users are not there. So think of all the other use cases, and there are plenty. And so, one of the advantages of a blockchain like XRPL, it's a great place to start because it's not too complicated and it does most things. Like it works well for most use cases. So most things that you would want to do on a blockchain, you could do on XRPL pretty easily. And then if you want to go, the more advanced route, you'll have learned a ton. There's many options in the XRPL ecosystem if you like it, and then there's other reasons to go to other chains as well, which are more specialized and have, many different features. Blockchains now, we have blockchains that specialize in just identity, or just even blockchains that are that connect other blockchains, connect blockchains one to another. So there's lots to do. I think XRPL is a great place to start. Well, because it's essentially an API. I mean, if you can, you can use an API in any programming language. We happen to provide SDKs, which makes things easier. But at the end of the day, all you're doing is interacting with an endpoint. So very easy. You can do this in any language. You can do this, from C all the way to. We have SDKs, really well maintained SDKs in JavaScript and Python, in Java to some extent. I know we have an SDK that's in Rust. I mean, it's maybe not as well a Go, but yeah. So we have a number of SDKs, but at the end of the day, it really is just an API call. And you could see the transactions that I'm sending are, they look like JSON objects, but basically that's what they are. I mean, they're not JSON on the back end, but it's basically a couple keys and values that your pairs that you're sending in a unified API. I could show you transaction types. There's about, I think now we're about, there's about 30 different transaction types. And they basically help you to do everything. So this part of the documentation is completely language agnostic. I'll just take something that you've seen. So there's all these things that I haven't talked about, obviously, but let's see, escrows. I don't know, payment. Sorry, I can't. Anyway, it was there. There we go. So this we used earlier. So you have, this is basically, it's completely language agnostic. These are the fields that you're passing through, and you're passing these through to the API endpoint. Yeah. Oh, wait, complètement. It's like what I did in Replit. That's how you would integrate it into your code. It's just you import the. In JavaScript, it's even easier because you have the SDK. I mean, for most languages that you would use, you'd have an SDK. So yeah, totally. We do that in the training. You'll see. Any other questions? Okay, cool. Thanks very much. If you want to, sorry. If you did want to reach me or Vera,